So we have another great day of speakers lined up for you. So first up, we have Professor Lorrie Cranor. She's probably one of the most well-known figures globally for privacy and usable security. And at CMU, she's the director and Bosch Distinguished Professor of CyLab, Security and Privacy Institute, and FORE Systems University Professor of Computer Science and Engineering and Public Policy, CMU. She directs the CyLab Usable Privacy Group, Privacy and Security Lab, and also co-directs the Privacy Engineering Master's Program. In fact, more recently, she's spearheading the effort in bridging the fields of robotics and privacy, which I'm very excited about personally. She has served as the chief technologist at U.S. Federal Trade Commission and also co-founded a startup, Bombat Security, which has now been acquired. She's a fellow of the ACM, IEEE, AAAS, and ACM Chi Academy. And today she'll be talking about user-centered safety labels for GenAI applications. Welcome, Professor Cranor.
All right, well, good morning, everybody. Thank you for getting up early. Yeah, I've done a lot of work on privacy, and I've done a lot of work on labels. And when I was asked to do work on AI labels, I said, well, I really don't know a whole lot about AI. And fortunately, my collaborators know a lot more about it than I do. And so, you know, we're doing it. Then when I was asked to speak about AI here, I said, well, I don't have a lot to say about AI, but maybe I can talk about our AI safety labels project. So I'm going to start off by talking about labels in general and mostly privacy labels, and then I'm going to talk about some of the fairly early, not yet published work, so hot off the presses, or not even pressed yet, that we're doing on GenAI safety labels. So start with. So back in the 1990s, which now seems like the dark ages, websites did not have privacy policies. And then the US Federal Trade Commission said, you should all publish privacy policies on your websites. And websites did, and this is what they looked like, and this is what they still look like, right? And so in the 1990s, there was a lot of discussion about, well, we have these privacy policies, and they're really not very useful to people because they're full of legalese and they're really long. And people said, why can't they look more like food nutrition labels? Like, food nutrition labels are short and succinct, and they're standardized. They all look the same. And it's true that they have some complicated vocabulary. We're not born knowing what carbohydrates are or cholesterol, but once you learn that, the same terminology is on every food label that you look at. And you can safely ignore them if you don't care what you eat. But then if you go to the doctor and the doctor says, oh, you need to be watching your cholesterol, you have a way that you can watch your cholesterol. Right? You can go find it on the label and you can actually do that. It's accessible to you. And it's very easy to put multiple food products side by side and compare their labels because it is in this very nice comparable format. Right? So when we think about how are food labels useful, well, they give you a quick overview of the nutrition value of the food. They let you check for something specific. You have a peanut allergy, you need to watch your sodium, whatever. You can easily check for that. You can compare food products. It also provides data that we regularly see articles in the popular press where journalists have gone and compared food products and told you, you know, these are like the least healthy things you can drink at Starbucks, and right, you know, and they can do that because this data is available. When these first came out, like 2 decades ago, there was some false optimism that it would solve the obesity problem. We would not have obesity because they would just read these labels and they would stop eating things that were not healthy for them. And there are so many flaws in that logic, right? Clearly they did not happen. Okay, so that was the goal. They did not meet that goal. But that said, I think most people still view food nutrition labels as a success, despite the fact that they did not actually solve the obesity problem. All right, so what about privacy labels? Well, the idea with privacy labels, if we could actually have them in a widespread way, is that we could get a quick overview of data practices for companies, for websites, for IoT devices, right? And we could compare privacy practices between similar products and services. Once again, what could be really useful for researchers and for journalists. But of course, they're not going to protect privacy on their own. Like, even if we had privacy labels everywhere, like, we still would have privacy problems, and I argue we still need privacy laws and, actually enforceable things to help protect privacy. But they can be useful. All right, so I'm going to tell you a bit about some of our efforts to make privacy labels real. But what about GenAI safety labels? Why would we want those? So with GenAI safety labels, I think the idea is to think about telling people about potential failure modes and safeguards that have been put into place. And I put a question mark there because I feel like we're really very early in the process of figuring out what a GenAI safety label is, but it seems like maybe there's some possibility of providing this information. Then people would be able to check for specific types of failures or safeguards. They could then compare GenAI apps. It would provide information to journalists. But again, these would not magically make AI safe just because we have labels. Right? So setting expectations about what we're doing. All right, so I'm going to start by telling you about some of our past and current research on privacy labels, and then some of our current and future research on GenAI safety labels. And I'm going to highlight some of the lessons along the way from privacy labels that I think may be applicable. All right, so one of my earliest forays into privacy nutrition labels was work with Patrick Kelly and others, which we published at Chi in 2010. We started probably 3 years before that, so this is pretty old. And we started with some designs that looked like food nutrition labels were black and white, and then we went and did focus groups, we did user testing, and got a lot of feedback, and we came up with this design that you can see has color, right? And what we see here is down the left column is different types of data that websites would collect. These were designed for websites. And across the top, different ways that websites will use and share personal information. And then the idea was that any cell that is red is a cell where they do that combination of data and use. And there's an indication as to whether you can opt out or opt in to that. And we can put two websites next to each other, and at a glance, we can see that the one on the left is doing a lot more with a lot more data. Right. And so we did user testing of this, and people liked it. It allowed people to actually compare privacy policies a lot more easily. And also we imagined that you could actually click on any cell and drill down and get more information. Right. So nice idea in the research lab, was not actually adopted. We've seen some websites take some pieces of it, but there is no adoption of this. All right, here's one that actually is adopted. Does this look familiar to people? Yeah. So in the U.S., most U.S. financial institutions will produce these standardized bank privacy policies and periodically send them out to you. These are actually produced, well, the design was produced by the U.S. government. There are, I believe, 9 federal agencies that regulate the U.S. financial industry. They got together, they hired some design consultants, and they came up with similar design. Then it went through multiple rounds of public hearings and public comment periods, and eventually they got to this design. It's actually like 3 pages long. This is the first page. There's a lot that I don't like about it, but there's a lot that I do like. And in particular, I like this table that's on the bottom half of the first page, where we have a bunch of different reasons that the bank can share your personal information, and then yes or no as to whether they do that, and then yes or no as to whether you have a choice of opting out of that. So this is actually pretty useful. But when this first rolled out over a decade ago, and I got these in the mail from all the banks that I was doing business with, I looked at them and I was like, oh, my banks are really bad. They're all invading my privacy. What is going on here? Right? And I came in one day and talked to my students, and I showed them, look what I got from my banks. And I said, I guess what we learned from this is that banks are bad. Banks don't protect privacy. This is awful. And my students said, well, maybe it's just your banks. Right? Maybe there are some good ones out there. And I said, well, how would I find them? So we wrote scripts to crawl the web, and we collected over 6,000 bank privacy policies. And because they're in a standard format, we were able to write scripts to parse them and put them in a database. It would have been better if they were in a metadata format and not PDFs that we had to parse. But okay, we were still able to parse the PDFs. It was just harder, you know. So we have this database. And we have a demo online. We're not updating, we're not recrawling. So the information is all out of date, but you can see proof of concept. This is what you can do when you have all of this privacy data in one place, because you can then, for each of those rows that I showed you in the last slide, you can basically sort on that and find out which of these banks share the least amount of information. So that's really useful. It could be useful to consumers if this was actually updated and available to consumers. It turns out it really was useful for regulators. We actually had one of those 9 financial regulators reach out to us and say, you have data that we don't have. Could you share it with us? And we happily did. And because it was hard for the regulators to get their hands on this information, and here we had it nice in a nice, box tied with a little bow, right? So this is really useful, and it would be nice to see more of this sort of thing. Okay, in the IoT device space. So we hear a lot about IoT devices and security and privacy problems, that people like buy a smart thermostat and then discover that it has a microphone in it. And you're like, wait, why is my thermostat listening to me? Right? Oh, nobody told me that. Or the smart video cameras that have security problems, and so other people are able to take control of your camera that is a baby monitor in your child's room, right? And so people say, well, I would really like to buy these devices, but buy the ones that have good security and privacy. Well, how do I figure out which they are? If you look at the packaging for these devices, there is no information about security and privacy. So about 7 years ago, Pardis Amami Naini, who was my student at the time, now she's on the faculty at Duke, she and my colleague Yuvraj Agarwal, we said, well, maybe we could come up with these privacy and security labels for IoT devices. And we did a whole series of studies with users in order to design these things. We found that end users wanted something like this, but they didn't know what they wanted. They said, we're not experts in this. So we did expert studies, and the experts came up with lots of information that they thought was essential to put on this. So what you see on the right is what the experts wanted, with tons of information. We figured that would be overwhelming to users. So what you see on the left is kind of the user-facing version, and then you could click on a link or scan a QR code to get the more expansive version. And so this idea of we can have it both ways, especially once we're going with digital files. We can have the simple and the expansive version. We don't have to debate which one should it be. We can do both. I think that's a takeaway, that if we're looking at AI safety labels, maybe we have different formats for it. But not only that, in this case, we imagine that this is actually, there is metadata, that we have, JSON files behind all of this. And so a user who doesn't want to look at it in this format could get an app that would present it to them in a different format. So for example, I had an undergraduate student built this app, and the idea is, imagine you're at Home Depot looking at the smart doorbells or whatever, and you just scan the QR codes of the product you're interested in, and it makes a side-by-side comparison table for you. And you can put in there and say, well, actually, I don't care about all of those things. There are 5 things I really care about. And so it will just show you those 5 things and show you how they compare, and maybe highlight in green or red, the good ones and the bad ones, right? So that you can make a decision. And that's easy to do once we have metadata in a standard format, in a standard place, and you can build an app to do whatever users would find useful to do with this information. So we've had a bunch of academic publications on this, and we started talking to companies that actually manufacture IoT devices and said, hey, would you like to adopt this? And nobody wanted to do it. And then a couple of years ago, more than a couple of years ago now, government started saying, yeah, this IoT device security and privacy is actually really a problem. We should have labels. And in Europe, there are labels that are coming soon. In Singapore, I think they're already here. And in the US, the White House, about 2.5 years ago, said, we will have a US cyber trust mark. They didn't say what it was, but we will have a US cyber trust mark. And they convened us. There were some industry convenings to talk about what this would be and how we would get there. It was all industry until we basically talked our way into the White House. So the person on the right is my colleague Yuvraj. He got invited to the White House for the discussion. And we came in and said, we actually have a proposal for how to do this, which nobody else had. The White House then delegated this to the Federal Communications Commission, which then had lots of public comment periods and basically said, this is going to be a voluntary standard, and we want to hear from industry what we're doing. So the Consumer Technology Association, the CTA, convened working groups. We had to talk our way into those. We've been participating, and now this has been turned over to UL, which they like certify your toaster won't explode and whatever. Okay, so now they've been asked by the government to administer this, and we are involved in their working groups. Unfortunately, the way it's going is I don't think we will get the big, beautiful labels that we designed. I think it's going to be a very simple label with not very much information, because I think that is more palatable to industry. And it will look like that thing in the corner. That's the only thing that we know, is that's what it looks like, for better or for worse, in my opinion, for worse. Yeah, but stay tuned. Okay, another type of label is broadband labels. So in the US, they actually decided like 10 years ago, the FCC was going to mandate that the broadband companies have these labels so you could shop for broadband. And this has nothing to do with privacy or security. This is just comparing price and bandwidth and reliability and things like that. That the Obama administration had kind of pushed this. The Trump administration tabled it. The Biden administration picked it back up. And then a few years ago, I got a call from the FCC, and they said, come talk to us about broadband labels. And I said, I don't know anything about broadband. I can talk to you about labels. And they're like, good enough, right? So I went and talked to them, and the question they had for me is, what do consumers want in a broadband label? And I said, well, how should I know? You have to ask consumers. And they said, well, yeah, we're a government agency, and it's too difficult for us to go ask consumers, which is true. So we're just going to talk to a bunch of experts and do the best we can. So I then went and talked to my colleague, John Piha, who knows a lot about broadband. He actually used to work at the FCC, and I said, how about we get some students together? And we did. We have Chris and Ellie. We could do a project to figure out what the FCC should do with broadband labels. So we did a very quick summer project, and we wrote a report we sent to the FCC. They took some of our advice. So this is what we suggested. This is not what the FCC label actually looks like. Theirs does not have any color on it. Theirs also does not have what I think is the most useful part of this label, which we realized that all of this numbers about the download speeds and the bandwidth and all of that, like, it doesn't mean anything to most people. What you want to know is it good enough that I can browse the web? Well, what about, can I stream movies? What if two people in my house want to stream different movies at the same time? Is it going to work? Like, that's what consumers want to know. And so we suggested some information like that did not make it in. But some of the other things we suggested did. And that is actively in use. The labels themselves, while I think they could be better, I think they're decent. One of the problems, though, is, where do you find them? Like, when you buy broadband, you're not buying a thing with a box that you can find it on. They are on the broadband providers' websites, but not in a standard place. And so I think work in progress, the hope is that they will get put in a standard place so consumers can find them, but better yet, so that web crawlers can find them and do the useful comparison tools. Because I don't really want to have to go to AT&T and Verizon and find them. I just want to put in my zip code, find out what broadband choices I have in my neighborhood and how they compare. All right, another project that we worked on, this was again with Patrick Kelly, was mobile app privacy labels. And so Patrick spent some time looking at what could we put in the App Store that would give people some very basic information about the privacy of their mobile apps. And he iterated a bit, came up with this privacy facts label, and then we wanted to find out, would this actually be useful for people? And so we did a lab study where we brought people in and we asked them to choose some apps for a friend who asked for help finding some apps. And we looked at what was their rationale. So half the people saw the usual app store with no privacy information, and the other half saw an app store where we had inserted our privacy facts. And what we found is that when you didn't have privacy facts, nobody mentioned privacy at all when comparing apps. And when we had privacy facts, everybody mentioned privacy. And in some cases, they made decisions based on privacy. Now, privacy wasn't everything. If it was, we probably would not have believed our results, right? So if people said, oh, look at these two apps, I've actually used this one and it's great, I'm going to recommend it. I don't care that it says it has bad privacy. Like, I know it's a good app, right? They would. But if they're looking at two apps and they said, I've never heard of either one of them, they both have pretty similar reviews, but hey, look, this one has much better privacy, I'm going to pick the one with the better privacy. So this seemed like, hey, this could be useful information to put into the mix along with the reviews and all the other stuff when people are choosing apps. So we told Google and Apple about this and said, hey, maybe you all should consider adding this to your app stores. That was back in 2013. Nothing happened for a long time. And then in 2020, Apple added privacy labels to their app store, and then Google added it shortly thereafter. And here's what they look like. So we were very excited, yay, in the App Store. And then we started looking carefully at what exactly they were putting in these privacy labels. And unfortunately, they're kind of confusing. So we decided to do some studies to find out what was confusing about them. The other thing was there were a bunch of like New York Times, Washington Post articles saying that not only are they confusing, but they lie. And so we wondered about that. Why are they lying in their privacy labels? So we took a look at what developers were doing when they were creating the labels. And we did a study. We actually got 12 iOS app developers to let us watch them create labels for their apps. And what we found is that they were just confused and they were making errors. All right, I'm sure there are some malicious developers out there who are purposely lying, but these developers were not trying to lie. They just didn't understand what the task was. And so there are a lot of things that are confusing. So let me show you what a developer has to do. There's a wizard. That seems promising. The first thing the wizard asks them is, does your app collect data? And okay, that's easy usually. All right, it collects data. So there are 32 data types in 14 categories. Which ones do you collect? As you might imagine, most developers do not take the time to educate themselves about all 32 types of data. And so instead, they just kind of go on their intuition. They then have to pick their data purposes. Again, they don't really fully understand them. Is the data linked to users? Again, they don't fully understand. Is it used to track users? I don't know what tracking is, but I think I do. So for example, Google Maps timeline tracks location history. So should a developer disclose that they use data to track users? Anybody know? Thinking yes. All right. Actually, the answer is no, because Apple's definition of tracking is linking data with third-party data for targeted advertising. It has nothing to do with location tracking. But most developers assume it's about location tracking, right? And so this is a problem. Also turns out that Google's definitions and Apple's definitions of the same terms are not the same, adding to the confusion. So then we did studies with end users. End users were just as confused as developers. On top of that, end users would see things they didn't like in the label, and they'd be like, I want to click on it. I want to turn it off. I know Apple lets you turn things off. But it turns out that that interface that Apple has to turn things off is not in any way connected to the label. You have to go find a separate interface, and users didn't like that. On top of that, with the Apple labels, you end up having to scroll a lot to see all the stuff. And people would see, oh, wait, location. Wait, they already told me about location. Wait, they're telling me about location again. And basically what they're showing you is all the different uses of data and then all the data used for each of those things. So you can imagine it's like a matrix, except they've unfolded the matrix into a super long list, and users don't get that at all. We did similar studies with Android labels, found similar problems, some different problems, and then we moved on to trying to solve these problems. So this is our first redesign of the Apple label, and notice we brought the matrix back. And it, not a surprise when we did the user study, it's a lot easier for users to understand it in matrix form than in long scrolly list form. And we're continuing to refine that. There's also been work on tools for developers. And the idea here is that if we can actually guide developers, maybe we'll get more accurate labels. So there's a few. The first one was for iOS. This one is for Google. Right. So lots of things that we'd like to see the mobile app ecosystem do to improve things. We really need developer tools. We need some automated verification. Like Google and Apple could actually check. They can't check everything, but there's a lot of things they could check, and they're not. They should. We need to make these labels easier for people to understand, and we needed to make it easier for people to find them. A lot of users of iPhones, like in our studies, didn't even know the labels were there because they'd never scrolled far enough to even find them. Okay. So now I want to move over to GenAI safety labels, taking all of what we learned. So this is work that I'm doing with Hoda Haderi, Hong Shen, Jason Hong, and a whole fleet of students. And we have started by asking a lot of questions. So who is the audience? Who would want to use GenAI safety labels? We think the answer is actually a lot of people, and so maybe we need layered labels. There's some end user use cases, but also developers might be interested. Maybe policymakers would be interested. We're also looking at what should be on a GenAI safety label, and we're trying to figure out that right now. That is kind of where we're stuck. Once we figure that out, then how are we going to get the information to generate a label? And then how can we present it so that it's actually understandable? So thinking about what should be on the label, there are others who have also thought about this and have proposed some ideas. It seems like maybe there's some sort of ingredients list, but we don't quite understand what that is. Maybe there's some information about legal compliance. What jurisdiction, what laws are you complying with? What choices and rights are you giving to users? And then what information can we give users that would help them avoid harm from using this GenAI application? So the first research study that we've done, and this is not yet published, is we were trying to understand the types of harms and risks that come from existing GenAI applications. And so my students, Megan and Wendy, along with others, but Megan and Wendy did most of the heavy lifting here. They went through some AI incident databases and categorize the types of risks and harms they saw for a large number of incidents. So they first constructed a taxonomy, which I'm going to show you a little bit of. And this was based on, there's been some prior work in building these taxonomies. And so they were inspired and actually combined a few existing taxonomies of GenAI risks and socio-technical failure modes. Then they used that and they applied it to 499 incidents. Let me show you how that worked. So they used primarily, there's two different AI incident databases that are publicly available. They include not just GenAI, but other types of AI. So the students focused only on the GenAI incidents. There were some that were in both databases. So after deduplication, that's how we ended up with 499 incidents. Okay. For each one, we labeled a bunch of things, but primarily we started by labeling the modality. So the output of the GenAI tool, was it text, image, audio, video, code, or some combination? Then we looked at the affected entities, who would be impacted by a failure here. In many cases, you could say that there are a lot of them, but we picked the two that we thought would be most affected, right? And so those included, we looked at different kinds of stakeholders. So there are interacting stakeholders who are the ones who are actually using the GenAI application. So that's the end user as an individual, or an organization that is using an application, or the developer or deployer. They are directly touching that application. But then there are also non-interacting stakeholders, and these include other people besides the end user who might be victims of something that this is doing, other organizations, the community, or maybe society at large. So with like misinformation, maybe it's society at large that is actually bearing the consequences of this. Okay. Then we also looked at risks, and I'm going to show you, we have a huge taxonomy of risks, but for each one, we looked at the two most likely risks associated with it. All right, so here's the huge list. Basically, across the top in yellow are our high-level risk categories, and then underneath we have specific types of risk, and I'm going to walk you through a few examples in a minute. And then we have socio-technical failure modes. So trying to understand if there's a failure here, what would be the underlying kind of reason for that? And again, we have a taxonomy. This one's a little bit smaller. And so there's 4 main types. We have some that are related to the design of the tool. So it may be the training data itself is problematic, and that is leading to the failure mode. It may be development and evaluation related. So these are things that in the process of developing it, maybe if there had been more testing, we could have avoided some of these failures. Then there's release-related failure modes. This is a great system, but people are using it for purposes it was not supposed to be used for, right? And we have kind of the release-related and then the use-related, which there's kind of some slight differences between. All right, so we made a lot of pretty pictures, a lot of graphs of what we found from these 499 incidents. And so we looked at who is impacted. And you can see individuals beyond the end user and society are impacted way more than the actual end users of these systems. At first we were thinking like, oh, we have to help protect the users, but actually maybe we need to help protect society, right? And then what we did here is we looked to see for each of these impacted entities, what were the underlying reasons that they were, what was the number one thing? So for end users, beyond the end users, malicious use was the number one underlying problem. And society, malicious use was. But for end users, it was actually hallucination was the number one problem impacting them, right? So this was kind of interesting. We again looked by different types of risks and saw who was impacted by each type of risk. And so here we've color-coded the bars based on who is impacted. And all the blue and purple colors are the non-interacting stakeholders. And the orange and red colors are more of the interacting stakeholders. And to make it easier to see, I'm taking away all of the non-interacting ones. And you can see there's not much left. Like it's a much smaller group of the interacting stakeholders who are being impacted here. All right, let's look at some examples. So this is an incident in 2019. Fraudsters cloned a CEO's voice and stole $243,000 from his company. All right, so this is a case of it was an audio output, cloning the voice. The affected entity was not the person who used the AI tool. They actually got the money, but in fact, the organization who had the money stolen was affected, and the failure mode in this case was a malicious use. The tool worked really well, but it was a malicious use of the tool. Okay, so oh, and I forgot to mention, so we categorize the type of risk as an impersonation risk and a financial earnings loss. All right, malicious use. Okay, so here's another one. A voice actor sued an AI company for using her voice without consent. Right, so in this case, the company basically took her voice and put it into their tool so that other people could generate sound with her voice. So again, it's an audio modality. The affected entity is, in this case, not an organization, but an individual beyond the end user. And the failure mode has to do with how they collected data. They did not have permission to collect her voice to use here. It's an autonomy and IP copyright personality rights issue. And you can see our design-related failure mode. Another one, 2023, deepfake image showing Donald Trump being arrested. Okay, so in this case, it's an image that was generated. It's the affected entities are an individual, Donald Trump, but also society at large, which was deceived into thinking perhaps that Donald Trump had been arrested. So this is an impersonation and identity theft, but it's also a political manipulation and interference because this was during the election cycle that this took place. Another one, ChatGPT writes Hangzhou traffic disinformation. So basically a user thought it was a joke, got ChatGPT to write a press release for their local city government saying that they're changing the traffic rules. posted that on the internet, and everybody's like, oh my gosh, they're changing the rules, right? And apparently chaos ensued, right? So this was a case of propagating misconceptions and false beliefs. It led to a temporary little bit of society destabilization, and this was a undisclosed or unwelcome use. You know, the user wasn't trying to cause harm; it was a joke. But yeah, you shouldn't really do that. I think it's the last one here. So 2024 AI generated papers manipulate Scopus rankings in top philosophy journals. Yeah. So apparently there are 3 reportedly fake journals that have had so many papers that it actually has changed the rankings of journals. And all of these fake papers were generated by GenAI. So this is a case, the risks here are overburdening the ecosystems, because now the journals have to do extra work to find the fake papers and get rid of them, right? So that's a problem, and then also a loss of creativity and critical thinking. All right. No, wait, I do have one more. All right, so defense lawyer using AI botches criminal trial closing arguments. And so in this case, there was a software tool, AI software tool, marketed towards lawyers, saying you can use this for all your legal needs, right? A lawyer used it and made a terrible closing argument that had all sorts of things wrong in it. And the person who was convicted of a crime then tried to appeal and get it overturned on the basis that their lawyer used this. The judge actually did not grant the appeal. They said that this person was guilty on all sorts of things that had nothing to do with the mistakes that were made in the closing argument, and it would not have changed the jury's opinion, and let it go. Nonetheless, there is a loss of confidence and trust and an erosion of due process that probably occurred here. It's also the case that maybe part of the problem was a lack of transparency about the model's capabilities and limitations. You know, that the perhaps there should have been more warnings to the lawyers of like, you should check this before you actually use it in a trial. Yeah. All right. So there are some limitations of the study we just did. We're focusing on individual incidents, and so we're not looking at harms that may accrue over time due to multiple incidents. And we're also basing this on a database of publicly reported incidents. Well, what kind of incidents get reported? It's the sensational ones. It's the ones that the media, gets excited about, or that involve famous people, or court cases, right? The mundane things, all the students who cheat on their homework in my class every day, right? There's a few of those reported, but not really as many as I know it happens, right? So we know that this is not proportionate to reality. All right, so as I mentioned, we are still trying to figure out what should be on a label. We're hoping to use this to help inform that, to try to understand where are the cases where the end user actually is being harmed and not all of these societal things, so that we can try to give information to the end user that will prevent harm. But on the other hand, maybe we should be looking at the societal things, because maybe if we labeled that, it would help the policymakers say, ooh, this is really risky from a societal level. Maybe we don't want this. So all things we are thinking about and trying to figure out where to go next here. So I will end there. Happy to take any questions. Yeah.
So I guess to kind of drill on your point about like who the relevant stakeholders are, who do you see as the most like exigent stakeholders to try to inform about the dangers of Gen AI? Is it the users, because maybe that's more tractable? Is it the higher level policy, like the high level harms that you need to inform policymakers about? What would be like your next step in terms of, okay, we're going to solve the biggest problem for the most people right now?
Yeah, I don't know. Yeah, I really don't know the answer to that. Uh, I think we need to kind of look at all of them in parallel and kind of see where we can make a difference. And it may be that labels are particularly good for one of those groups and not others. And it remains to be seen. Yeah.
Oh, maybe while others are thinking, so one question. So, I mean, we heard a talk yesterday, like about implicit biases in systems, and that seemed to be missing from the matrix that you had. Although it could be included as a sort of an implicit part of some of the categories, but it's not explicitly stated. Do you think that that should be there?
I feel like it's in there somewhere. Yeah, I should add, like, I should have gotten Megan and Wendy here to answer these questions because they spent a lot of time thinking about it. But yeah, I think so. All of these things have definitions, and I think bias is part of the definitions of a bunch of different things. Yeah, and so for example, erosion of due process, I mean, human rights, and that may be due to a bias issue. Um, and I think a lot of the failures of common sense reasoning actually sometimes occur because of the bias issue. So I think that does actually show up in a bunch of places. Yeah, it might be interesting to look at yeah, where all the places are that it comes up. Yeah, I'm going to take that back.
Thank you for the talk, Lorrie. Maybe one question from my side. The study that you showed where you kind of identified these mismatches between, definitions of like tracking or collecting data and so on. So I'm not sure I understood how then did you approach that? So how you develop systems to do this disambiguation semi-automatically or automatically? Did you try to reconcile these definitions in any way? It's been a minute, but I remember that this NSF AI frontier project we were working on usable privacy policies, where we were able to kind of disambiguate a little bit semantically the different policies and displaying the definitions and tagging some of those, which make me think maybe we were tagging wrongly because we were not disambiguating the meaning of tracking or other things. So.
Yeah. So I guess there's sort of two prongs that we're looking at here. One is, can we come up with clearer words that are less ambiguous to begin with, and have a clear definition? And we're actually in the middle of doing a study right now to try to propose some clearer language. And then the other is to try to help the developers so that they know what it actually means. And so the two different tools that I showed you for developers, first of all, they do use some automation to try to guess what's going on and to say to the developer, it looks like from your code, this is what you're doing. Is that right? And we see that you collect this data. We can't tell from your code what you're doing with it. But here are the most likely things that people do with this data. And oh, by the way, tracking does not mean location. So basically putting those tips in for developers. So those are the two approaches that we're looking at.
Other questions? While others are thinking, so one more question. So, like so do your studies also span across different cultures? Because I would think that, since you started with the food labels, like if I see what's important on a food label in the US versus in India, it's completely different, right? I've never looked at a food label in India, but I always look at food labels here. But what's important in India is like a red dot or a green dot, meaning is it fit for vegetarians or not, right? And that's the only thing that people care about. you said like the privacy labels are there in Singapore, Europe, and US. Are there noticeable differences across cultures that need to be amplified, or?
Yeah, so the IoT labels, I don't think the differences there are cultural. I think they are more political. What could get passed in in each jurisdiction? I don't think it has anything to do with culture. But that said, I think in privacy there definitely are things that are cultural and contextual. I think a lot of data collection, though, is not particularly culturally situated. I think people's views on what is okay to share and that is clearly, different countries. Some people will talk freely about their income, and others, you never mention your income, and things like that. But as far as corporate use of your data, I'm not sure that is actually really all that different around the world. But again, the difference is what politically we're able to mandate in different parts of the world.
I'm going to be honest, I don't have like a fully thought out question, but just a train of thought that I'd like your opinion on. So even for non-AI products, there's always new releases. So is there a way that safety labels are updated as each release is released?
Yeah.
And then also applying that to AI products, since those are continually updated as even end users are using it. I guess how has your team like try to combat that issue?
Yeah, no, that's a great question. And so for the IoT devices, the discussions that we've had are, when you buy a physical product, what's in the box is what's in the box, but it might have a firmware update, or if it's sending data to a server, things change. So it's really important there that when something changes, that there is an update and that it's pushed to the device so that like, oh, there's an update. If you care, you should actually go look at the new label. So since we're dealing with stuff that's connected and digital, we can do that as long as someone remembers to go and update the label. Similarly, even website privacy policies, when those first came out, companies were like, oh, every time we change our data practices, we're going to have to update this. And anecdotally, I worked in industry at the time. The fact that you would have to update your label, and there was also at the time there was a certification in which my company had, you have to update your label and become recertified on your privacy policy, caused companies to actually not go willy-nilly start collecting new data. Like, it actually they're like, oh, let's think about if we really want to do that, because if we start doing this new thing, we are going to have to update our privacy policy and update our certification. So some people argue that hampers innovation, but I think that's actually a good thing to put the brakes on a little bit. It's not that hard to update your policy. So I do think that's important for data safety labels. Again, we have no idea what's actually going to be on them, but imagine that there's information on them about how many incidents have occurred, or how risky this is. And maybe we have something that seems like nobody's ever heard of a problem. It's not risky at all. And then tomorrow something bad happens. Right, we would want to let people know that something bad happened yesterday, right? And so thinking through how to make sure that we can keep these as up to date as possible is something to think about. Yeah.
Maybe one more thing to add. So like the labels that you had earlier, like privacy labels, had more to do with like what the companies themselves were doing, whereas I think it's more of the GenAI labels go more towards, are also taking into account the end use, right? So sort of referring to the first question, like, do you, just from a benefit point of view, do you see that, do you anticipate that based on the end use, the companies who are making these GenAI systems will change the way that they make the systems, or put more guardrails or stuff like that? Do you anticipate that things like that will happen as a result?
Yeah. So I'm hoping that when end users see these labels, it will help reinforce what are appropriate and inappropriate uses. So, similarly to how nutrition labels tell you this contains peanuts, right? And oh, I have a peanut allergy. I should not eat this, right? Imagine that legal software, if it had a warning that said, you should not use the output of this in court until you've reviewed it, right? I mean, some lawyers are probably stupid and would still not review it, but maybe those sorts of things, saying this is not safe to directly put in your legal proceeding. Treat this like the intern who brainstorms the ideas, but then you go and check it, right? So it's possible that some of those types of use-related things could be helped with a label. Of course, if it's a malicious use and it says, warning, this could be used to hurt people, and the malicious user is like, yes, that's what I want. I want to hurt people, right? So.
Yeah.
Hi, great, really interesting talk. The thing that you mentioned just now brought up a question I remembered from earlier. So I'm not familiar with the legal tool that you described, but given that it was probably made by people with some level of legal expertise, I'm imagining they did have some kind of disclaimer written in some kind of legal text, which probably resembled a privacy policy, which seems to take us back to the original instantiation of a different problem. So maybe what I want to ask is, are there nuances that maybe give you more hope about simplifications, abstractions, visual ones, nutrition labels being more effective for generative AI than the privacy case? More general question, do you see similarities and differences there that make this an easier or more difficult problem?
Yeah, so definitely problem of getting people to read things. I think, the parallel in the legal cases, yeah, undoubtedly there was some sort of a disclaimer, which probably said, we don't guarantee that anything is reliable here. And so, which is problematic because an end user is like, right, you told me to buy your product and now you're telling me I can't trust your product to do anything. Right. And what we need is something more nuanced. Like, these are some of the better things to use my product for, and these are some of the worst things to use my product for. But most likely it just said, don't trust it ever, for liability reasons. So if we could get at that nuance, that would be nice. Honestly, there's, in the label, in the privacy label world, there hasn't been a lot of success. Arguably, the financial labels, I think, are the most successful because they're actually deployed in great numbers, and they are not ambiguous, right, for the most part. Like, they actually are pretty, or at least the table part is pretty clear. There are other parts of it that I think are ambiguous, yeah, I think with AI safety labels, we need to think about who is the actual target audience and how can we have something that's actually clear, and then how do we actually get it deployed. Without a law requiring deployment, what we've seen with privacy labels is, yeah, you're never going to get them adopted, or if you do, it's like Google and Apple decide to do something weird that no one understands, right? There does seem, in talking to companies, the developer perspective actually seems to be the things that companies are most interested in right now. So I sort of feel like, well, maybe there's hope there. If companies actually want this for developers, maybe that's something that they would voluntarily adopt, at least the developer view of these sorts of things. I'm also, like, I heard from the financial industry, they're a highly regulated industry, and so I've heard from them that they have to make disclosures about their use of AI. And so they're thinking, oh, maybe a label would make this easier for us, right? And so if you have an industry that, because of regulations, already feels like this would fill a need, then they're more likely to actually adopt and use it. So I think we're going to be looking for those sorts of things.